Hello, everyone, and welcome to Beyond the Forecast on this Martin Luther King Jr. Day. Great to be with you. I'm StormTracker8 Chief Meteorologist Matt DiNardo. Of course, everybody wants to talk about the potential snow for Saturday, right? Big storm possibly coming, a lot of things. And what we're going to do here is we're really going to go through some of the models. They're just coming out with the 12Z run begins coming out around 9:30 through about now. Then we'll start to get the 18Z runs coming in soon. And by the way, just in case you didn't know, we work in Z time, Zulu time. That keeps all weather across the globe on the same clock, and it makes it easy to figure out what's going on. And then, of course, we have to change it to our own local time. Before we get going, I thought this was a pretty cool little stat in weather history. I'll just bring this up here for you. It was back in 1857, a severe snowstorm came across the mid-Atlantic, and there was a lot of snow across the interior sections of central Virginia, and it actually cut Richmond from D.C. off. Like, you couldn't travel northward by, I guess back then, right, horse and buggy. It was just way too much. All right, before we get into the potential snow, I'm going to tell you a little thing why I'm always cautioning you as to what you might be seeing out on social media. I've already had reports, people sending me messages on Facebook saying, hey, I see the storm coming up on Saturday is going to give us 26 inches of snow. Or somebody else says, I just saw it said 14, and then it dropped to 6 2 hours later. All the things that you're seeing on either apps or Facebook posts are based on one model. That is not meteorology, folks. That is modelology. That is wishing for the stars and hoping that that star is going to be there. That's all that is, okay? So please do not do that. And here's why that 26-inch amount makes no sense for Richmond. These are the top 10. These are the top 10 snowfalls, not snowiest winters. These are top 10 snowfalls for Richmond. Singular storms, which might have crossed, as you see there, several days. The number one biggest storm didn't even hit 2 feet for Richmond. So when you see somebody post a model and says 26 inches for Richmond, you immediately have to say, is that really possible? Sure, records are meant to be broken, but records have stood for a reason. The storm that many of you remember, the blizzard of 1996, do you see it on that list? It ranks number 11, having 11 inches officially at the Richmond airport. Yes, many of you west of 95 picked up 15, 18, 24 inches. Big storm. Don't get me wrong. But it didn't fall at the airport where the official measurements are kept. You're saying, well, who cares? As George Carlin said, nobody lives at the airport. He used one of his 7 dirty words to describe that. But the point is, yes, that's where the official records are. So when you see somebody posting a model that has 26 inches at the Richmond airport, scratch your head a bit and say, that's a lot. Most of our really good storms are a foot to maybe a foot plus a couple of inches. You see there's a number in there, 17 to 12, like number 3 to 10. Those are really good storms. Really, really good storms. Just kind of cautioning you as to what's going on. All right, so let's talk about what is going on. What is the potential? So we're going to bring up the models, and we're going to look through a bunch of these models together. These, again, are the new models that have come out, and we'll start with, for those of you weather enthusiasts, we're going to start with the European model, and we're going to look at the surface potential radar situation, and we'll look at the QPF amounts, the amount of moisture that they're popping out here, just to give you an idea. So we're going to start off on today, and we're located right there, right? Central Virginia's right there. So there's really nothing happening today. We're nice and quiet. I'm just going to page us ahead. All easy stuff. High pressure slides over us tonight through tomorrow. So clear tonight, cold tomorrow, beautiful sunshine. A little weather system approaching us here later Wednesday afternoon into early Thursday. That's partially significant. Let's continue on. That weather system crosses through Thursday. See the little reflection here in the heights, or the isobars, I should say. The height, the thickness is falling behind it. There's our front. This is a little piece of an Arctic front. And those numbers there, 540, 538, 528, those are really important. That's what we call thickness. That's how, basically, how dense the cold air is. And the lower the number, the more dense it is. That's kind of a very simplified method. So when we bring this ahead and we get into Friday afternoon, I'll stop it right here. You see the 540 line, and that's an important line, by the way. That's usually thought of as the rain-snow line, but there's other factors is well to our south. The 534 is kind of through central Virginia, 528 across northern Virginia. So when we start to get into those numbers, we know we got some snow falling, or at least the cold air for the snow to fall. There's nothing falling here. Now, I want you to take a look back to the west. I want you to look back into Texas. You see this rain here and a little bit of ice, a little bit of snow? This is the developing weather system as of Friday afternoon. Again, this is the European model. Now you're going to notice how that really starts to explode as we get into early Saturday morning. Look at that. We're sitting here at about 2 a.m. Saturday. Got rain, got ice, got sleet, got snow, got a massive winter storm developing. And over time, that is going to press to the east. I'm going to stop it right here. Let's go back into central Virginia. Remember I said that magical 540 line? Look at where it is. It's way down south in southern North Carolina, almost down to Wilmington. We're sitting at 528. So we are definitely cold enough to see snow. And this system is pushing its way to us. Also notice something else if you're a big model person and you've been looking. You notice, this seems a little bit later. Wasn't it in some of the other models snowing at this point? It was, actually. And this may still speed up. We'll be watching that over the next couple of days. But we advance it ahead here, and we get into Saturday night, early Sunday morning, and it's snowing like the dickens out there. Look at the deep blues and the purples. And again, you look at the numbers down here. That's intense stuff. These are snowfall rates and all. That's really good stuff coming our way. All right, we'll continue to push it ahead. Here we are, first thing Sunday morning around 8 o'clock, 7 o'clock in the morning, and now it's wrapping up, but it's pulling away, and it's done in the afternoon. Now, that was just the European. And if we just look at the total QPF, this is the amount of available moisture coming out from this model. It's going to appear on your screen in just a second here because it's loading all the parameters in. You're going to see the European puts up a tremendous amount. If I just kind of drop it on Richmond right there, 1.33 inches of liquid equivalent. That's a lot. And if you were to say, well, wait, isn't 1 inch of rain equal to 10 inches of snow? It can be. It also can be that 1 inch of rain equals 6 inches of snow. It also can be that 1 inch of rain equals 50 inches of snow. Lake effect in upstate New York and downwind of the Great Lakes. There's a lot of things we have to look at to figure out what our snow ratio is going to be. How cold will this system be over us? Not just at the ground, but aloft. And we can look at that. We can go into some of the upper air. We can go look at the 850 temperatures just to give you a quick idea. And we'll go into that same period here as we jump ahead. And here we are. Let's go Saturday as this is starting to snow, Saturday night, early Sunday morning. So we come back in here. We're minus 13 at 850 centigrade, minus 12, minus 13. You can see the number there on your screen, right? I'm kind of pulling that up there for you. I'll pull this maybe full if I can. I'm not sure if I can. Media full. There we go. And so you can see that minus 12 that I'm talking about. So in a standard kind of thing, when we're looking at this, and we're looking at 850s, if I see minus 3 to minus 5 centigrade at 850 millibars, that's high in the sky. We measure the altitude by millibars. I might be thinking, this is a 10-to-1 ratio. When I start to see minus 10, minus 11, minus 12, minus 13, and by the way, we're actually getting colder a little bit during the storm there too. We're now thinking this could be maybe 18-to-1 snow ratio, meaning 18 inches per 1 inch of liquid equivalent. Well, wait, hold on. Didn't we have 1.34? So if we grab my phone, and again, this is just, I'm just giving you some ideas of some of the things that we go through and we look at, and I'm doing it as quick as possible. So if I do 1.34, right, 1.34 on my phone, and I times it by 18, holy cow, 24 inches of snow. That's what the European is showing. Yeah, but that's just right now one model, right? We're on Monday. We have Tuesday, Wednesday, Thursday, Friday to Saturday. We have 6 more days to see how the models trend. Now, we like to give you the earliest best call that we can, usually about 3 days out. That was one model, folks. Let's change it back up here, and let's go into we did the European. Let's go into the GFS model. Let's just kind of page through this. Let's go to the same type of thing. So we're going to run through. We see high pressure over us. Again, great weather. Cold tonight, tomorrow. There's that same front maybe coming through. This is early Thursday morning. No big deal. That passes through Thursday afternoon, and it starts to bring in. Here's that 540 again, right? That's bringing down. That's sliding down. And now as we get into Friday afternoon, the 540 is through southern Virginia, maybe through central Virginia, 534 to the north. Look back to the west. Here's your snow or your rain in Texas. This is going to become our developing storm system. See how it's developing here? Man, that's a lot of mess in Texas, right? You got some rain south. You got some orange, which is your sleet. You got your purple, your orange is your freezing rain. Your pink or purple, which is your sleet. Your blue is your snow. Notice how it's now bringing snow into central Virginia. We'll tack this off just a bit. Here we go. 12Z Saturday morning, so around 8 o'clock in the morning, starting to see some light snow breaking out. Here we are at 2 o'clock in the afternoon. Saturday, it's snowing. And by the way, did you notice those 528 thickness there? So it's cold, right? It's even a little bit colder than the European. The low developing, too, is farther south and east. Why? Because the GFS is resolving the high in Canada stronger and pushing some colder air in and deflecting some of the heavier snow south of us. All right, so let's go back and let's just look at the total QPF again. Again, this is kind of a little more technical type of discussion, but I think it's kind of warranted because you're all interested in this. You love to know what's going on. So we put it on, the GFS only has a half inch of liquid, 0.49 or 0.45, depending on how you move it. And then that 1.34 is way down in central North Carolina because the GFS is saying, hey, that cold air is going to be stronger. And it slides the system south of us and develops that coastal system off the coast of South Carolina, then off of northern North Carolina. So that's a significant difference just in 2 models alone. Well, let's just quickly go and look at that 850 millibar temperature, right? Because I want to know, well, how cold is it going to be? So remember, the GFS started the snow earlier. It started it early in the morning. It's already 12 degrees centigrade, minus 12 degrees centigrade at Saturday morning. Let's just push it ahead. And here we are, same time now, it's 13. So we're going to 2 o'clock in the afternoon. Let's go to Saturday night. It's 11. So it's a little bit colder. And now it's really, you see the purple's kind of sliding in by the time we get into minus 15, by the time we get into Sunday morning. At that point, did you notice that, by the way? Let me just roll that back just for a quick second here. Remember, the European had the snow going later Saturday afternoon, more like Saturday evening, all the way through Sunday, whereas the GFS, that snow's done by 10 o'clock in the morning Sunday, right? It's gone. So 2 significant differences there. I'm not going to go as crazy as we did, but we can go look at the Icon, which is another model that we often use to go looking into the future. When we're talking greater than 100 hours, we use our long-range models because the short-range stuff can't see it. When we start getting inside of about 60 hours to 100, we use a mixture of our medium-range models and our long-range models. When we're inside of 60, we really want to be using our short-range and our medium range models. Because the long range, the grid point spacing, the information, the data spacing is pretty wide. That's why it can go out farther, because it's using different physics, but the data points are more spread out and we can cover more area. When we have our real high resolution models, like the HRR, the 3K, which are 60-hour or 48-hour type models, there's a lot of tight grid points, and that gives us higher resolution, but we can only go shorter time spans. All right, so back to the icon here, by the way, just to kind of show you this. We'll just kind of, there's that little front coming through. Now we're watching North Texas. There's our, across Arkansas, whoops, let's clear that off there. Across Arkansas, so a little bit farther to the east, we have our freezing rain and our snow to the north of that, and that's Saturday morning at about 8 o'clock in the morning. And notice the low developing there in southern sections of Alabama and Atlanta. We're seeing snow here by Saturday night. And then that storm is developing off of the southern North Carolina coast, and it's done by early Sunday morning. And just to kind of show you the amount of QPF in this one, just to kind of throw this out there as it comes up, this is going to be a lot less. Oh, sorry, moved a little too quick. There we go. 0.34. Again, it certainly is colder. It's farther south as well. Then, of course, there's the Canadian model. And this is going to do some crazy things. Just to kind of show you. This storm. Oh, whoa, totally different solution. Totally different solution. It places the high in a different location that gives us more of a northeast wind, has more of an overrunning scenario where we're pushing warm air into cold air at the ground, and that's why you see lots of purple there, because this is producing more of a snow, sleet, maybe some freezing rain scenario. So that's interesting how it does that, right? So that's pretty interesting stuff, right? Now, do I think that's right? Personally, no, I do not. I think the answer probably lies somewhere right now, if you were to put my feet to the fire, somewhere between European and GFS. And I'm just looking at singular model runs for you, just kind of give you an idea. We look at some of the ensemble models. We get an idea of what they might be doing, and we'll look at different things inside of this. These are just temperatures that popped up automatically. It's not what we'd be looking at. But you get the point. There's lots of things. So there's an interesting thing you want to do when you're looking at models, or you see somebody posting models on social media. You want to say, well, does that make sense? Is it producing, as we talked about just a few seconds ago, the biggest snowstorm ever in Richmond? Certainly, it could happen. But logically, does that make sense? Or does it produce a good-sized storm? And it depends on what your definition of good-sized storm is. I think anything over 6 inches is a good-sized storm. Or is it producing a bigger snowstorm? Anything over maybe 12 inches, let's say, right? So those are some things you want to look at when you're seeing, and you're going to see a lot of crazy stuff over the next couple of days. And when you look at the apps on your phone, some of those apps are putting out numbers already. Ours, the StormTracker8 app, the app that we use, pull this up here for you. If it looks like, let's see, the center one right there, right? So we're going to hit the StormTracker8 app. That's what it looks like as it comes up here. And it loads up here, and we go to the thing. We go to daily. Daily. And I'm just going to bring it to. So ours does not show you numbers in terms of a forecast, okay? And the reason why is because those are things that we have to put in there. We control our app. If you just open up the standard weather app at an Apple, an iPhone or an Android, it's reading one model. That's all. It's just model-based. That's how they're done. And most television stations, their apps are singular model-based. And there's a reason why we didn't do that, is so we could control the forecast so it's representative of our forecast coming out to you. That's what we do there. So we'll continue to watch all the models. We'll continue to look at the development of this storm. We'll continue to see how this is progressing. And again, new models are going to come in starting soon, in fact. Let's see. I mean, and again, I mentioned so right now, the 18Z HRR, the HER, as we often call it, is coming in. It's through 8 hours. But this model only goes out as much as, I'll just pull it up here for you just so you get an idea. It only goes out 48 hours. So that's not going to help us. That's going to carry us into Wednesday right now, right? We're looking at something Saturday. But there's tons of models. And by the way, if you're interested, we use Pivotal Weather as one of our forecasting tools. They have all the models here, as you can see. There's no secrets there, right? The models are open, and we'll continue to interpret them, and we'll continue to look at them. So that's just something that I wanted to bring to your attention today because there's a lot of excitement, a lot of hype on this. All right, really quick, let's talk about what's going on in the short term. You kind of saw it right now. All quiet out there for Martin Luther King Jr. Day. You see a front passing through. That's an Arctic front. We're going to be back down into the teens tonight. Tomorrow, highs only lower to maybe mid-30s. Plenty of sunshine. You see that high sliding across into northwestern Arkansas, right, coming on down. That's going to crest over us and be with us tomorrow and also Wednesday. Then we'll have another front coming through. That'll be an Arctic front on Thursday. That'll start to set the stage for that particular storm coming up for Saturday. Now, if we think back really quickly to this past weekend, right, we had that rain-snow mixture. And last week, when we were 5 and 6 days out, the models had trouble resolving that system because it thought the cold air was going to be more dense, deeper, dig a more of a discernible trough, bigger dip in the jet stream, if you will, and the GFS namely, blew up the storm. And others did not. And people were posting, we're getting a big storm, but look at this. And we didn't get a big storm. We had rain and we had some mixed in flakes, and maybe some of you had your ground covered. And that's why I kept saying early last week, don't hype. Don't read the hype. That's clickbait. It really is. Again, when we're doing the forecasts, we're looking at everything. We're figuring out which models are making sense, and not just in the models themselves, model to model, right? Like in terms of GFS to Euro to Icon to Canadian, et cetera. But we're also looking at run to run. Right, the models come out at 0Z, 6Z, 12Z, 18Z. Those are the main times, right? There are some models that come out hourly now, of course, too. But we're looking at those. Do they make sense run to run, right? If I'm seeing, let's just use an example here, in the European. If I'm seeing a particular outcome that's maybe producing a ½ inch of liquid, and the next time it produces 0.6 of an inch of liquid. Okay, that makes some sense based on it looks, and all of a sudden there's this weird blow up in one run, and all of a sudden we have 2 inches of liquid. Something's wrong, right? Because if the next run comes out and it's back down to 0.56 inches of liquid, right? But now everybody's now posted that saying, look, the European's going to give us blah, 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 blah. Again, that's why you've got to look at things. You got to go slow into these things. It's better to slowly bring things up than come out with this gangbusters type of forecast of, 24 inches, let's say. And then all of a sudden, 24 hours before, like, yeah, this thing's like 3 to 6. That's what we're trying to do. Temper the expectations. Anyway, all right, really quick, with all that being said, here's the 8-day forecast just to pull this up. Again, low to mid-40s today. It is kind of breezy out there as that Arctic front comes through. 19 here in the capital city tonight. Tomorrow, 38. Some of you might not even get above 32, 33 tomorrow, especially north and west. We're at 16 as we go into Wednesday morning. Wednesday and Thursday, 43, 53. That 53 will be before that Arctic front comes through. Then you notice how we drop off on Friday to 42. And then, yes, it is going to be colder as this snow moves on in. Snow developing on Saturday and ending Sunday, some late day sun. You notice I actually have adjusted the times on this because in my 32 years of doing this, typically this far out, the models are running about 6 to 12 hours faster or slower, running slower, meaning coming in at 7 p.m. when they're really going to come in at 7 to 10 a.m. So something to keep in mind. So that's why I have more of a snowy day on Saturday. We'll continue to update you on all of this as we go through the week. I hope you all have a wonderful afternoon. And again, just enjoy, folks. It could be a snowstorm, and some of you snow lovers will be happy. Have a great one.